Hello, my name is Maria from mathmammoth.com. In this video, we're gonna look at the slope-intercept equation. Here I have line 1. Its equation is y equals 2x. It's already drawn here. It's a line through the origin. And here's a table of values for it. A partial table of values, naturally. We don't have every point here in the table. But for example, 0, 0 here is included. And then x is 1, y is 2. So it's 1, 2, this one here. And then x is 2, y is 4, 2, 4. And then x is 3, y is double that, 6 here. And so on. If x is negative 1, y is negative 2. And then line 2 is not drawn yet, but there's a table of values for it. Now compare these two tables of values. The x's are the same, from -2 all the way to 5, and goes by ones. The y values, if we compare them to these here, here's -4, here -5, here's -2, here's -3, 0, and then -1, 2, and 1. You notice that each time the y value here for the line 2 is just exactly 1 less than the corresponding y value here in line 1. So no matter what the x value is, the y value is just exactly 1 less. So for example, here's 0, 0, but for line 2, this point is included. And here's 2, 4 over here, 2, 4. But for line 2, this point is included, 2, 3, exactly 1 less right there. Or if we look at this point, for line 2, there will be a point right there. Or this point, it's going to be a point right here. So it goes like this. That line is basically as if we took line 1 and moved it 1 unit down. Now what is its equation? Can you guess? Each y value is exactly the same as the y value here, -1. 2x minus 1. Yes, that is the equation. We can check it, for example, when x is 0, then this is -1. 0 minus 1. When x is 2, then we get 2 times 2 is 4 minus 1, 3. Yes, that works. Now what about line 3? Where do you think that will be in relation to these other two lines that we already drew? Its equation is y equals 2x plus 3. Notice it has the same slope, 2. Each one of these has the same slope, the same steepness. And that means they are then parallel lines. They are equally steep. Y equals 2x plus 3. In comparison to this blue line, which was y equals 2x, this one is exactly 3 units up. So for example, over here, instead of this point, the origin, it's going to have this point. Over here, instead of this point, it's going to have a point just 3 up, over there. This is how it looks like. Alright, like I said, all 3 lines are parallel and have the same slope. But you can think of them as, okay, you can take this one and move it up or down to get these others. Every linear function has the equation of the form y equals mx plus b. We have studied the m is the slope, or the rate of change. We have studied the b also when we studied linear functions. It was the initial value, but in the context of graphing, we have a new name for it. Here is an example line, y equals mx plus b, and I have noted here the run and the rise between 2 points on the line, and that's where the slope comes from. We calculate the slope as a rise over run. This point here is the initial value. When x is 0, then y is b. We call it the y-intercept. That is where the line intercepts or intersects the y-axis. The b is y-intercept. M is the slope. Now look at these two lines. One of them is through the origin, so its equation is y equals mx, a simple equation. M is the slope. And the other one is y equals mx plus b. So it differs by this b, the y-intercept. If you compare the two, the latter is b units higher than the former. Over here, this vertical distance is always b. This point here is the y-intercept point, okay? And b as a number is called the y-intercept. Alright, now we're gonna use this knowledge to graph these lines. This knowledge that y equals mx plus b, that the b is the y-intercept and m is the slope. Each one of these lines is in this format, where we have y equals some number times x plus some number. Okay, the number may be negative, but still, they are all in this same format. So we can see that for this first line, the slope is 3/5, and the y-intercept is 4. This means that it crosses this y-axis at 4, over here. You can also just plug in 0 in place of x and calculate that the y equals 4. When x is 0, y is 4. And then we'll use the slope, okay? Once again, we'll draw the rise and run triangle, or run and rise. Which one is which? Rise over run. Rise over run. The run is 5. The rise is 3. And this is a positive slope, so the line will be ascending, going up. Here's my 2 points, so now I can draw it. It's gonna be a little bit of an eyeballing. I will draw another point, go 3 and 5, like that. So there's that line. Next one, we have slope -2, y-intercept is -5. Here. So this line goes through this point, and its slope is negative, so it goes down -2, okay? So slope is -2, I can write it like this. So I get my rise and run. Run is just 1, and the rise is -2, or down. Here's my second point. Or I could go like that, get another point. And again, there's the line. Last one. Try this yourself too. Kind of imagine, where is the line gonna be? My y-intercept is 2, this point. Slope is again positive. Rise over run. So I'll draw my triangle somewhere here. Run is now 3. And rise is 8. Okay, I can't do it. It's gonna be over there. So I will go this way instead. 8 and 3. 8 and 3. Over there. And then, sorry for eyeballing the lines, they're not fully accurate, but you get the idea, okay? And this is all for this lesson. I hope this was helpful.